Hi everyone! Welcome to another biochemistry tip. Today we're going to talk about fatty acid structures. And as you can see on the screen, there's a lot you need to know about the fatty acid structures. But today we're just going to cover part one, the 4 different types of fatty acid structures. And as you can see, we need to know how to count the double bonds in these structures and the number of carbons in order to answer questions. However, because we're not covering all the information you see on this list, I highly encourage you to start with this video as a foundation and then go into the online textbook and the practice questions in order to apply this information. Biochemistry is all about application, and so you need to practice as much as possible. Okay, so let's look at the 4 different types of structures we might see for fatty acids. Let's start with the full structure of these fatty acids. What you can see here is we have in every fatty acid a carboxylate group, or sometimes we call this a carboxyl, and we have a hydrocarbon tail. If these hydrocarbons and carboxyl groups look familiar, that's because you may have seen the same thing on amino acids. However, the combination of these groups is very different. We have just the carboxyl group on the fatty acid, and then several of these CH groups to make a long tail. And to make different types of fatty acid structures, the tail length will be different. And so the carboxyl group is universal. Every fatty acid has a carboxyl group with those 2 oxygens attached to a carbon. But then the number of hydrocarbons on the tail may change, and so might the double bonds. So you can see here if we have no double bonds, we have a saturated fatty acid. And if we have at least one of these double bonds, we have an unsaturated fatty acid. And so if we see a structure like this with all of the atoms and all of the bonds drawn out, we can very easily visualize the double bonds. So there's one double bond here, and we can count the carbons. Now it's really important to remember that every single carbon counts for the purpose of the questions you'll have to answer. So in this saturated fatty acid, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. And in this unsaturated, we have 1, 2, 3, 4, 5, 6, 7, also 8 carbons. But you might notice that while we have 8 carbons in both of these structures, we have a different number of hydrogens. And that's because of the bonding rules with carbons. Carbons can only make 4 bonds, and they have to make 4 bonds. And that's why we see that we'll lose hydrogens when we make a double bond, because we have to make room for that double bond. So let me show you what I mean. What you can see here at the end of the saturated fatty acid is we have a carbon connected to another carbon. That's making 1 bond. And then to fill in the other 4 bonds, we have hydrogens added. Then in this next group, our carbon is attached to 2 other carbons, and so we only need 2 hydrogens to fill in the gap. If we go all the way to our carboxylate group, this carbon is attached to 1 other carbon, and then it has 1 bond to 1 oxygen and 2 bonds to the other oxygen. So it's already making all 4 bonds and therefore doesn't have any hydrogens attached. Now let's look at the double bond. This carbon here has 2 bonds to the carbon to the right, 1 bond to the carbon to the left. So it's already making 3 bonds, and therefore it only needs 1 hydrogen. So when we make a double bond between 2 carbons, we actually lose 2 hydrogens to make room for that bond. 1 from the carbon circled here, and 1 hydrogen is lost from the other carbon it's attached to. Now this is important because we can draw out these formulas in different ways. So we have 8 carbons in this saturated fatty acid, and we start on the right side with CH3. Then what you can see is with these carbons, these 6 carbons in the row, they're all CH2s. So we can actually abbreviate that. We can just put a CH2 in parentheses like this and put a 6 outside the parentheses, and that will indicate that we actually have 6 CH2s. And then we have our carboxylate. So that will be COO minus. We can do the same with the unsaturated fatty acid, but now we're going to indicate the double bond. So we still start with CH3. Then we have one CH2. Then we have a CH that's double bonded to another CH. Then we have 3 CH2s in a row and our carboxylate again. And so this is the second way we can look at the structural formulas. And so that's what you can see here at the bottom. Here's 2 fatty acids that now have their abbreviated formulas. Now we could draw these out with all of their atoms and all of their bonds, but you're not going to have to do that for the test. What you're going to have to be able to do is count the number of double bonds and the number of carbons. So here we have 2 double bonds indicated by this kind of equals sign. And in the second one, we have 1 double bond. Now to count the number of carbons, we have to take into account the parentheses. And remember, every carbon counts. So we have 1 here. Then this 3 outside the parentheses means there's 3 CH2s in a row. So now that's a total of 4 carbons. There's 5, 6. Now we have 2 more, so that's 7, 8, 9, 10. There's 3 here, so that's 13. 14 carbons. Don't forget that carboxyl carbon. And in this bottom one, we have 1, and then 6 in a row. So that's 7, 8, 9, 10, 11, 12 carbons. So what you can notice here is that even though this one is drawn out much longer, it's actually only 2 carbons longer. So we can't go based on the length as drawn out. We have to count those carbons. Now, another way we can look at these formulas, the third way, is with these just little crinkle structures. And with these crinkle structures, every valley and every peak represents a carbon with the appropriate amount of hydrogens. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons here. And we could draw this structure out as CH3 at the end here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 CH2s in a row. And then our carboxyl group. Now, if we looked at the next one, there's a whole lot more. And if we look at C, we can see the double bonds now. And D has 2 double bonds. And so that's how we would count the carbons and see the double bonds in these structures. And don't forget, the CH3 at the end counts, and so does the carboxyl carbon. And so if we were to answer this question, polyunsaturated, poly means multiple, unsaturated refers to double bonds. So D with 2 double bonds is polyunsaturated. And we would call C monounsaturated. Now, there's one more way to look at these fatty acid structures, and that's with chemical formulas. You might see something like C6H12O2 or C6H8O2. And if you see that, it's pretty clear how many carbons they have, but we can't really see the double bonds drawn out. And so there are a couple of rules to make sure you know how many double bonds these have. The first thing is that if it is saturated, then there is twice as many hydrogens as carbons. And so that's what we see here, C6H12O2. This is saturated because there is twice as many hydrogens as carbons. Another important thing is that fatty acids always have 2 and only 2 oxygens. So we see that's fine for both of these. Now the third thing is that every double bond loses 2 hydrogens, like we said before. And so if we looked at this second one, we would see that we don't have twice as many hydrogens. So we know for sure this is unsaturated. And to determine how many double bonds it has, we would just see how many we're missing. So if this was saturated, we would have 12 hydrogens, but we only have 8. So we're missing 4 hydrogens. That means there must be 2 double bonds, because every double bond loses 2 hydrogens. So if we're missing 4, we've made 2 double bonds. And so this would be another polyunsaturated fatty acid. Now let's look at an example of this so you know what a question might look like. So this says, what is a possible chemical formula for a monounsaturated fatty acid? So if we follow our rules, first of all, we know that these fatty acids only have 2 oxygen. So if we look at these here, we can immediately eliminate this one and this one because they have too many oxygens. So that's a quick way to immediately eliminate what is not a fatty acid. Fatty acids only have 2 oxygens. Then it gets a little trickier. Monounsaturated means 1 double bond. In order to determine that, what I usually like to do is look at what the fatty acid would be if it was saturated and then go from there. So both of our remaining oxygens are C8. And remember, if it was saturated, it would have twice as many hydrogens as carbons. So this would have to be C8H16O2. So if we're looking for monounsaturated, we're making 1 double bond, so we lose 2 hydrogens based on the saturated. So we're looking for C8H14O2, which is what we have right here. So that's the 4 different ways to look at fatty acid structures. We have our chemical formula. We have these crinkle structures that we can use to count the carbons and fill in the hydrogens. We have these abbreviated formulas here. And then we have the fully drawn out structural formula. Now you're never going to have a question that asks you, how many carbons does this fatty acid have? Instead, you're going to have to apply this information to things like identifying the omega, looking at the fluidity of the bonds, and even in beta oxidation, the breakdown of fatty acids. And so I encourage you to now go into the online textbook to learn about the rest of these things to do with fatty acids, and then do some practice questions to apply the information. If you need any assistance, please feel free to call your biochemistry course instructors. We're here to help you. I hope you have a great day. Bye now.